Okay. Start screen share. Oh, you're live.
Hello, everyone, and welcome to the online workshop series on the First Tech Challenge. We are very excited to have you all here today. This workshop is brought to you by the K-12 STEM Education Center at NYU School of Engineering in association with New York City First. First, let me introduce you to my team. I have Dhawal on my left and Raghu on my right.
Hey, guys.
And I am Rishabh. We are all grad students at NYU School of Engineering, and this workshop is being broadcasted live on Google Hangouts. Our Gmail address is centerfork12stem@gmail.com. We will be taking questions during this workshop, and we highly recommend you to ask questions through the chat window. We will try our best to answer all of these questions today. I want to speak a little about our workshop. Our workshop is divided into 4 days. Today is day one. The dates for the remaining workshop are in the description of this live stream. So let's jump right into it. And so, Dhaval, what's our agenda for today?
Yeah. So today we are going to cover basics of NXT Lego brick, basics of sensors, basics of basics of motor, and also basics of robot C programming. I highly recommend you to watch FTC problem statement for this year. It's on their official YouTube channel. And let's start with introduction to robotics. Can we have the presentation?
Yeah.
All right. So let's start with the definition of a robot. So how exactly can we define a robot? It's a machine or a system which performs user-defined tasks on its own or via teleoperation, and we will see how. So basically, robotics is divided into two parts. The one is the manual mode, and the other one is the autonomous mode. As you know, First Tech Challenge consists of both of them. The initial part will be autonomous round, in which a robot needs to do certain tasks on its own without any manual intervention, and it will be followed by a manual control mode where you will be controlling a robot with the joystick. So why why do we build robots? Robots help us to learn teamwork. They help us to develop problem solving skills, and also they help us to build logic. And you will see this as you participate in such competitions.
Take your time, fill the form.
Yeah. Dhaval, you can start talking.
We need the microphone.
Yeah. Dhaval, can you start?
Yeah.
Yeah.
Alright.
From my mic.
Okay, I'm sorry, really sorry. There are some technical difficulties. But what we're going to do is we're just going to use the secondary laptop, and you might not be able to see us, but we have the presentation. So I hope you all can see the presentation, and I hope the audio is going through. So we'll have the audio and the presentation for the time being. And so let's start.
Yeah. Right. So what will we use to make our robot? So we'll be using NXT brick, as you can see in the picture, and we'll be using several other sensors and actuators, which I will cover later. Okay. So what does anatomy of a robot looks like? So it has a brain. So what's brain? Brain. So in our robot, NXT brick is actually the brain of the robot, and then we attach actuators. Actuators are the things that which helps the robots to do physical things and interact with the physical world. And then we have sensors. Sensors gives feedback of what's actually happening in the surround, and it gives this value to the brain. And then we have power supply. What does power supply do? Well, it powers all these three components of the robot: that's sensor, brain, and actuators. And then we have interface, that's display. Interface helps human beings to like see what's actually going on in the brain, have some feedback from the brain itself. Then we have, so what you can see here is NXT Lego brick, and this is what it looks like. It has output ports where you can connect actuators. We will see it in a bit. It has a USB port through which you can program your NXT brick. It has an LCD interface, so you can debug quickly. Then it has some buttons for menu navigation on it, selecting programs, running it. And then you have input ports where you can connect different sensors. So sensors. So what exactly sensors are? Sensors are the electronic devices which help us to convert any physical quantity into electrical quantity which a computer can measure. For example, touch sensor. So what touch sensor does is it. Sorry.
No, you're muted.
Okay. Presentation. It's on? Okay. Sorry about that. So what this sensor does is it detects whether the robot is touching something or not. And as you can see, the first one is what that sensor looks like. Then we have light sensors. So what light sensor does is it gives you the feedback of how much light the robot is receiving. Then we have sound sensor. So sound is measured in decibels, and it gives us the level of sound that's in the surrounding of the robot. Then we have sonar sensor. So what sonar sensor does is it measures the distance of the robot from any object like a wall or a ball, and it gives you values in centimeters. So you can use all these sensors to make your robot smart, so it can navigate autonomously and do various things. Then we have actuators. So this is what NXT basic motor looks like, and you can use this one to help your robot to move forward to do various tasks. Uh, so this is a very low power motor. You might not be actually using this one because for some applications we need very high torque motor which are available with Technics kits, and we'll see in a bit. Uh, then we have a power supply. So you might have all got rechargeable power supply with the standard kit. I highly recommend you to use that. But apart from that, during competitions, I highly recommend to keep a separate set of 6 AA batteries. So in case if anything goes wrong, you still have a backup and your robot can function. This is the basic interface display which we will see in this like following workshops, how to display different values and graphics on this display. And so what will I use to build a body of a robot? Well, for this particular challenge, we have a kit named Tetrix kit, which will be having aluminum channels and different parts with it, which you will be using to build your robot. And you actually need to have a rough sketch of the robot, and then you need to model it in, like I recommend you to model in 3D CAD modeling software and then move it from there. Okay, so finally, how do I command my robot? Well, as our robot is based on a computer, we actually need to write a code, and we'll be using robot C for that. Uh, and don't worry, we'll be starting up with the basics of the robot C, and it's fairly easy to code in it. So let's start with robot C programming.
Yeah, before we start, we will just try to pause and see if we have any questions. If you have any questions, please post your questions in the chat window. If you do have any questions, we will have a look at it. Okay, so seems like we don't have any questions right now. So let's start with the programming bit of our workshop today. So can we have the presentation? So this is very similar to instructing your pet to probably fetch an object or fetch a ball or something like that. So these instructions are instructions written by you and fed to the robot. So you can say things like, robot, please turn left, robot, please turn right, please move forward. Obviously, the instructions are not going to be this simple. We are going to be writing cryptic code to actually make the robot understand what we're trying to say. We all know that machines do not really understand the English language, so we cannot say something like, robot, please turn right, and the robot will turn right. That's not going to happen. So we need to write some instructions in a language called C. I hope that most of you are familiar about this language. If you all haven't programmed into it, we are going to do that today. We'll start with some basic programming. But my point is that that the robot needs zeros and ones to understand the instructions. So, and obviously it's not convenient to write zeros and ones and instruct the robot. So we are going to program in C and the language C, and see how we can go ahead with that. So so here are some online tutorials that are going to be very helpful. First is the robotc.net website. You can have a look at that website. There is a set of documentations available on this website. So we can go on this website right now and see how the documentation looks. Or Yeah, can we pull that out? Okay. So yeah, so that was the RobotC website. So there's www.robotc.net, and the next one is an online tutorial on YouTube. It is by Skylar Porky. I hope I'm pronouncing his name right. So it is called RobotC for NXT tutorials, and it's a set of 10 videos. I highly recommend beginners to go on YouTube and start with this tutorial. It is very helpful. And so moving on. So what are we going to really need to program our robots? So first, we need to write our instructions somewhere. So people who have basic knowledge about programming, they know that you can write programs or instructions in something as simple as a notepad, but we are not going to be using that to program our robot. We need something more sophisticated, which is an IDE. An IDE is sort of a notepad program on your computer where you can write instructions. Um, IDE is short for Integrated Development Environment. So we need to download this IDE called Robot C. Go to the download section, download this IDE. It's a trial version. And the second thing that we obviously require is a robot. We need to build a robot using the next NXT brick, some sensors, and actuators or motors, whatever you would like to call them. So these are two basic things that we need to program our robot. The program that we're going to write it in, the IDE, and the robot itself. Okay, so unfortunately, Robot C is available only for Windows, and you're going to get a trial version when you download it. It's going to be a 30-day trial version, and Mac users will not be able to use Robot C on their Macs. They need to install Windows before they're able to use Robot C. So yeah, so that's what it is. Next. Okay, so this is the first screen that we're going to see once Robot C is successfully installed. It has nothing on it right now. You're not going to see any place where you can write. To actually be able to write, you need to go to File, go to New File, and then create a new file where you can write your instructions. So what are we going to do today? Today, we'll configure the robot, its sensors and motors, so that they can take instructions from Robot C. We need to connect the robot to the computer so that we can take, so the robot can take instructions from Robot C. And we'll perform two activities. One is activity 1, which will be using a touch sensor. And the next activity is activity 2, which is using a sonar sensor. So a sonar sensor is basically an ultrasound sensor which gets the feedback from its environment about the proximity of an object to it or something similar. Okay. So yeah, enough of this presentation. Let's jump right into writing code, and we'll pull out the screen for you now. Okay, so our NXT brick is first loaded with the Mindstorm firmware. Now, firmware is something which is capable of taking instructions from a computer. So we need to first flash the firmware of this NXT brick and install the new firmware, which is the Robot C firmware. So when you connect your robot to the PC using a USB cable and try to write a program to it. So let's do that. Let's connect the robot to our PC and let's try to write a small code.
So Dhaval, I have a question here. What all motors did we connect here? Like, which sensor, which ports are we using?
Okay, so here for motors we are using port A and port B for both the motors, and for the sensors we are using input port 1 and input port 2 for both the sensors.
Okay. So once we have all this connected to the robot, the two sensors, and the two actuators. These are the two actuators down here. These are the two sensors. This is a touch sensor. This is an ultrasound sensor. We have all of this connected to the respective USB ports.
So Rishabh, so totally we are having two sensors and two motors, right?
Yes, that's what we have. So let's try to connect the robot via USB cable to our PC. So this is the USB cable which goes into our PC, and small program on this brick, and let's see what happens. So every program has to start with a task main keyword. So task is something which tells the robot that it is supposed to perform this action, and main is where our program is going to start, and it is followed by some round parentheses. These parentheses instruct that the task is a function, and inside the main we are going to write some code right now. So we write motor and in square brackets motor A, indicating that we are going to be using motor A, which might be connected to an actuator connected to a wheel. So we are going to do that and give it a value of 20 right now. So a value of 20 indicates the speed of the motor that it is going to turn at, and to the motor B as well. And let's try to run this. Okay, so we have saved the program, and now let's try to go to robot, compile and download program.
Oh wow, Dhaval, Rishabh, I keep getting this error when I try to download my code. So what exactly is the error? Can you tell us more about this error?
Yeah, so your NXT brick is first loaded with the Mindstorm firmware, and we need to firmware with a different version. So we are going to write our code in robot C. So the robot C firmware is supposed to be loaded on the brick. So let's try to do that first. Let's try to flash the firmware of our NXT brick.
So is that what it's telling in the pop-up window here?
Yeah. So it's saying NXT controller is not loaded with robot C firmware. Reload firmware with robot C firmware. So we're gonna go and do that right now. So we go to robot, we go to download firmware, and then we have the standard file NXT. Now over here in the window, we are first going to try to see whether our NXT brick gets detected or not. We can see that it is detected here in the window. Okay, so now we can just hit firmware download, and that's going to download the firmware for us on our NXT brick. Okay, so while we download the firmware on the brick is going to turn off, and after that it's going to make some ticking sound indicating that, I'm not sure whether you can hear the sound, but it's going to go tick, and that's how we understand that the firmware has been downloaded. This sound says that it's successfully completed, the firmware has been downloaded, and now we are all set to write programs for our NXT brick. Okay, so now we have the initial program, which is task main, and it says that I can use motor A, which will turn at the speed of 20, motor B, which will turn at the speed of 20 again. The values range from 0 to 100, and wait 1m sec is a function which asks the robot to perform motor A running at the speed of 20, motor B running at the speed of 20 to go on for 1 second. We specify the value in milliseconds, so 1000 milliseconds is going to make 1 second. So motor A and motor B are going to run at the speed of 20 for 1 second, after which motor A is being given the value of 0, motor B is being given the value of 0, which indicates that the motors are going to stop turning. Okay, so now we can go onto robot and say compile and download our program onto the brick. And now we can see that the start button has popped up, so we can click start, and there we have it. So the robot moves. What happens here is that motor A moves at the speed of 20, motor B moves at the speed of 20, which makes the robot go ahead, obviously. And this happens for a second, and after that we turn off our motors, motor A and motor B both. So we can hit start, and that will actually run our motor. So that was the basic activity number one. We saw how we can move both the motors using a simple program in C language. So if we have any, if I highly encourage you all to post questions. If you all have any questions, please post them in the chat window. We'll be taking questions and we'll try to answer all of them. Um, so that was activity number one. A very basic activity. Motor A, motor B, both run at the speed of 20. We do that for 1 second, and then we turn off both the motors.
Okay, Rishabh. So what is this step into? What is this option? Can you explain us more about this step into?
Okay, so the way we program a robot is that we go step by step, performing each instruction one by one. So it's called procedural programming. Every instruction starts from line 1, then the instruction at line 2 is performed, then the instruction at line 3 is performed, and so on. So what step into does is we try to see what is being executed on the robot on every line of code. So if we hit step into right now, so let's go ahead and do that. Step into. Now we hit step, so that turns our control to line number 4, which means that motor A will be turned at the speed of 20. After hitting step again, now we can see that motor B starts turning at the speed of 20, and next is line number 6. Then we have line number 7 and line number 8. So this is very helpful in debugging your robot, so you can go line by line and see what action is your robot performing. So I highly encourage that.
Okay.
That
Rishabh, can we do that again along with the demo, with the video showing the robot?
Okay, sure. So yeah, we're gonna yeah. So we start the robot. Okay. So
Can we have the video?
do we have the
For the
video?
No?
We don't have the
Fine.
video.
So
Okay, never mind. So I hope you all get the basic concept of how you can program your robot using robot C. So now we're going to move on to some sophisticated programs that make our robot do different things using the sensor, because the ultimate goal is to be able to read what is available in the environment and have a robot work accordingly. So let's start a new program. Let's start with a new file. Okay, so what the IDE does is it starts you off with task main written, and so this is because we are programming it into robot C. So robot C knows that we are going to need task main, and inside of task main we will be using the touch sensor. Okay, so the touch sensor basically has two values to it. If the touch sensor senses that it is being touched, the value is toggled to 1, and if it is not being touched, the value is toggled to 0. So there are just two values to touch sensor, 0 and 1, true or false. Most of you will be familiar with the data type called Boolean. So the touch sensor takes a Boolean value, which is 0 or 1 or true or false. So let's start writing the code to harness the touch sensor.
what do we do first? Rishabh?
So first we need to what we need to do first is configure our touch sensor. Tell our program that we're going to be using a touch sensor. So we need to configure it. So we go to robot. We go to motors and sensor setup. After that, this window will be popped up and it has a few tabs called standard models, motors, and sensors. So we go to sensors tab. We select the type of sensor, which this is going to be a touch sensor. We can give it a nickname over here, and this is basically going to indicate which sensor are you using using the name. So it's just a friendly way to indicate or sort of understand which sensor you're going to be using while you write the code. Okay, you hit OK, and we can see the first line automatically generated by robot C. And this looks a little cryptic, but we don't really need to worry about that right now because we're just starting to program. All we need to know is that in the fourth parameter of this line, we say that they're using a sensor touch. The sensor is attached to the first USB port. That's why it is called S1, and we can use this sensor S1 to write a program and to take and to read values from our environment. So we start with the task main again, and first what we're going to do is we're going to try to read the value of the sensor. So we're going to say sensor value S1 in square brackets, indicating that we're going to be using the first sensor. And we check this value to be equal to 1. So as y'all can see, we write this line of code into an if condition. Now, what an if condition does is that it checks for a certain equality or a non-equality. So when we say if sensor value S1 equal to 1, it is going to check if the sensor has the value 1 in it. If it does not, then it's not going to follow the code written after that. But if it is 1, then whatever we put in the curly brackets is going to be executed. So this is a basic if condition which checks whether the sensor value is 1 or not. So if the sensor value is 1, whatever is in the braces will be performed, and if it is not 1, we put those set of instructions in the else braces. So we start with the if condition. So if the sensor is being touched, because it's a touch sensor, it will have the value 1, and if it has the value 1, we want to stop moving the robot and make it go backwards. So what we're going to do is we're going to say motor A. So now this is the good thing about robot C. It automatically suggests what you might want to use. So you can just write M, and then it will pop up motor A or motor B or motor C. So we have given the values of -20. This will make the robot go backwards. If the sensor is touched, it has the value 1. So we check for that value in the if condition, and we make the motors go backward. Okay, and so when we want to make the robot go forward, we need to put all of that code in the else condition. But we also want to make the robot turn when it is being touched. So when it hits a wall, the sensor value goes 1. We want to make it go backward, and then we want to turn the robot in a certain direction. So the way you turn a robot is basically by giving a value of 0 to one of the motors, and a value of anything between 0 to 100 to the other motor, and this will make the robot turn. Okay, so we performed this for like 2 seconds, and now we want to write the code for making the robot go ahead. So we're going to write all of that code in the else part of the program. We're going to say motor A 20, motor B at the speed of 20, and this will make our robot go forward. Okay, so now we want to put all of this code and make it happen or make it work all the time. So to do that, we write a while condition, and in a while loop, our condition is set to 1, indicating that it will always be true. So this basically makes our robot keep going in this loop and keep checking for the sensor value. If it is 1, it'll stop, go backwards, turn, and then start moving ahead. If the value is 0, the else part will be executed, and if the value is 1, the if part will be executed. So let's try to compile and download the program. So I hope we all can see the robot. So let's start the robot. This is the touch sensor. So if this value is turned to 1, which is after being pressed, the robot is going to stop, move backwards, turn, and then start going ahead again. So let's try to see if the robot follows our instructions. Let's hit start. The robot goes ahead, and then okay, so okay, because due to space constraints, we cannot really.
Okay, let's do that again.
Okay, let's try to do that again.
So we have a code here. I'll start. The robot is going forward. It hit the touch sensor. The sensor value is 1. It went back. It took a turn again, right? Is that right, Rishabh?
Yeah. So what we can do is we can change the values in our code over here. We can make the robot turn for more than 2 seconds, which will set it back to the same path. We can say 3 seconds, and then the robot is going to turn for 3 seconds. So let's see if that happens. Okay, so it works. So that was activity number 1, and we saw 2 specific things in this activity: the if condition and the while loop. The if condition checks for a certain value to be true or false, which we indicate in the round parenthesis.
So Rishabh, what did you change in the code? We just changed the turning time, right?
Yeah, so we make motor A and motor B turn for 3 seconds, which we indicate in the wait1 msec function. So we just changed the value to 2000 to 3000. That made a robot turn for 3 seconds.
Good.
So so here are the takeaway for this program. We use the if condition and we use the while condition. In the if condition, we check for a certain value to be true or false. So when we write if sensor value s1 equal to 1, we check for the value of the sensor, whether it is 1 or not. If it is 1, we perform a certain set of instructions. If not, we put our instructions in the else block. So if the value is not equal to 1, then we make the motor A and motor B go at the speed of 20 at the same time. And that is how we can use the sensors. The touch sensor was number 1. And yeah, do you have any questions, Ravi?
Yeah, Rishabh. So can you tell us more about the while one thing here, which is on line number 6?
Okay, so the while loop, so the while line of code is actually a loop. So from instructions number 7 to instruction number 21, all these instructions will be performed again and again till the value is true for the while condition. So we check for a condition in the while loop saying 1. So 1 means that it is always going to be true, and since the value is 1 and it is always going to be true, our loop will keep on running.
You
And
mean I can have a conditions or something like this?
yes, you can have conditions like this. This is also true because you're comparing the sensor value to 1. This is a valid condition, but right now it won't work because what we really need to check, the loop won't run until unless we have the value set to 1, and the value will be set to 1 only when the touch sensor is pressed.
Oh.
So it does not make any sense right now to check for that condition in the while loop.
So you just don't want to check anything, and you tell him to do this again and again without actually checking anything.
Exactly, yes, you're right, Raghu. So right now in the while condition, we do not want to check anything. The while condition is just to make the robot perform instructions number 8 to instruction number 21 again and again. So we're just gonna say that it's always true. The condition is always true, and keep running these set of instructions.
Okay, Rishabh, I have a question. Like, let us say I don't have this while loop at all. Will this work? What happens when the program reaches the end of main? Like, say the end of main is task main is line number 23, right? So what exactly happens there?
Okay,
Will the program stall, or will the program run again?
Exactly, the program will stop running because it is just going to check once for the value to be true or not, and once it is done with that, the program will stop running. And you don't want your robot to stop running. You want it to keep going ahead and perform the instructions again and again, and that is the exact reason why we put all of that code in a while loop.
Cool. So basically, you're trying to do those instructions again and again and again inside the while loop.
Exactly. So the while line of instruction is actually a loop which tells the robot to perform the instructions which are in the while block to be performed again and again.
Can I have this thing while of true instead of while of 1?
Yes. So the conditions can always be either true or false. There is no third value to a condition. And some of us with a basic knowledge of programming would know that a true or a false condition is actually called a Boolean value. So anytime we check a condition, be it in a while loop or be it a if condition, we're always going to have either true or false. In the if condition right now, we have sensor value s1 equal to 1. So if the sensor value is equal to 1, a true condition will be returned or a false condition will be returned. So ultimately that condition is going to have only two values, either a true value or a false value. So in all the loops we check for such a condition which can take two values, and an if condition we also check for such values which can either be true or false. So you can very well go ahead and write true, and that will mean the same thing. 1 is equal to true and 0 is equal to false. So the while loop is all values always true.
Okay, that was perfect. So what is the next activity which you're going to do?
So the next activity that we are going to do is we are going to use a sonar a sonar sensor. So what the sonar sensor does is actually it tries to measure the distance between itself and the object. So it sets a signal from one of the lenses that you can see, maybe you can see it from here, and it receives the feedback on the other sensor, on the other lens. So a sonar sensor basically transmits an ultrasound, and it tries to measure the proximity to an object, something like a wall, or say the tube that is one of the goalposts in our game challenge. So so we're going to use the sonar sensor now in activity number 2, and let's start writing the code for that. So we have the task main, and let's write the first line to check the value of the sensor. So let's say okay, before that we need to configure our sensor. So we go robot, after that we select sonar and give it a name. Let's call it my sonar sensor. Let's hit OK. There we have it, first line of code automatically generated by robot C. It says that we're going to use sensor at USB 1 in USB port 2. So let's change that in a line of code. Let's make it S2. Okay.
So let me just give you a quick heads on like how exactly sonar sensor works. So the way it works is, so as you can see, there are you can see two circles on it. So one is the transmitter and the other one is the receiver. So it sends out the sound signals and then waits for the sound signal to hit something and reflect back and receive the signal in the receiver. And the time taken by the sound to travel back, so it's divided by 2. So it actually goes somewhere and then comes back. So if you have that, so if you know the speed of the sound in air and if you know the time, then you can actually calculate the distance if any object is from your robot. So that's how sonar sensor works.
Okay, thank you, Dhaval, for that. So now let's try to write the first line of code for our sonar sensor. So let's check for a condition now. Let's check what the sensor value is. So we're going to write an if condition, two, since it is connected to port number 2. And we're going to check for the value in this sensor. Let's say if the distance is more than 10, now the unit of 10 is actually 10 centimeters over here. So if the sensor value is more than 10, so we're going to perform a certain set of instructions if that condition is true. If it is not true, if it is false, then we perform the lines written in the else block.
Okay, Rishabh. So how is it different from the touch sensor? Like how is the value of the sensor different from the touch sensor value? Because
Okay.
in touch sensor value we just had 1 or 0, right?
Exactly. So in the sonar sensor, we're going to have values from 0 to 255. So 0 to 255 actually correspond to the distance in centimeters. Theoretically, it is 0 to 255, but practically we can only go up to 160 centimeters. And any object beyond 160 centimeters is going to be out of range and will be considered as beyond 160. So it is going to be beyond 255. So if we want to check for an object which is beyond the range, we can say sensor value S2 to be greater than 255. If that is true, then we perform certain instructions. If that is false, we perform the instructions in the else block. So let's try to write what is going to be performed if the sensor value is more than 10. So if the wall is, for example, if you consider a wall and it is at a distance of more than 10, then we want the robot to go towards the wall. So we say motor A equal to 20 and motor B equal to 20, and that is going to be in our if condition. And in our else condition, we make the robot stop if it nears the wall. So so we check for the distance between the wall and the robot, and we make the robot go ahead. If the distance is less than 10, then we're going to make the robot stop. Now again, all of this has to be done again and again. So we put all of this code into a while loop. So we write while equal to true. So this is always going to be true, the loop, and we're going to perform lines from 9 to 19 again and again in a loop. So let's see if that works for us. Let's try to compile a code and run it. Always necessary to indent your code. So okay, make sure that your next brick is turned on. We hit compile and download program. Let's start the program.
So you want to show the demo?
Yeah, we show the demo now. So quick start. Okay, now the robot stops because it senses a value of less than 10 centimeters. If I remove my hand, the robot keeps moving ahead. But if I Yeah, so it measures the value of it basically measures the value of the distance between my hand and the robot. So
So let us say it's going forward. So right now you mean to say the robot is currently executing the else part?
right now it is executing the else part because the value has become less than 10.
Okay.
So the value becomes less than 10, the robot is actually going to stop. But if the value is more than 10, if I remove my hand, the value is more than 10 and the robot keeps going ahead.
Okay, that's cool.
So that was activity number 2.
Mhm.
And we would like to take some questions. So let's see if we have any questions.
So it looks like we don't have any questions right now.
Mhm.
Okay, so we'll try to solve some basic problems over here that we could have. We need to really understand the code for when we write our robot C programs. Robot C is very helpful uh, in suggesting probable instructions that you might want to execute on your robot. So it will automatically put task main when you write a new file. Uh, the other lines of code have to be put in the task main. Be sure to check your parentheses always. So when you start a parenthesis over here, you always end it somewhere after you finish writing the instructions. And same goes for the if part. So the if block starts on line number 9 and it has to end on line number 12. The else part follows the same sort of standards. You have to close the parenthesis. So here we close the parenthesis on line number 17. And we always end our lines of instruction with a semicolon. So if you miss a semicolon, the robot C program is going to give you an error. So here on line 14, since we did not write a semicolon, the program gave us an error. So we're going to always end our instructions on every line with a semicolon. So we can see the error says that expected semicolon, and it did not find that. So we're going to go ahead and put that semicolon over there to get rid of that error. And also, if we miss any parentheses, so let's unbalance or remove a parenthesis here, and let's try to run our program. So it gives us an error. And what does the error say? It says that it expects a brace which was not found. So these are some of the common mistakes that all of us tend to do. So make sure that the code is thoroughly checked, otherwise it's going to give you errors. So that's it for today. We learned about the NXT brick, and we did some basic programming in Robot C. We're very sorry for the technical difficulties today, and we're going to be having our next workshop on the 26th of November, same time. It's a Wednesday. Be sure to follow us on Facebook and on Twitter. Our Twitter handle is Center for K-12 STEM. We post our updates over there on our Facebook page, on our Twitter account. So we're going to see you next time, uh, and hopefully we won't have any technical difficulties next time. So we'll see you at 4 on Wednesday, on the November 26th. And I also need to remind you about the clinic, which we will be hosting here at NYU Poly. It's a program for everyone to participate in, where y'all can we'll have the field set up, so y'all can bring your robots and test your robots in the field. We'll have the complete setup with FCS. So I highly recommend you all to come to this clinic on the 23rd, which will be hosted here at NYU Poly.
Yeah.
All right. Do we have anything else?
No.
All right. See you next time on Wednesday. Bye.
Thank you.